Hello, everybody, and welcome back. We're going to be starting a new chapter. This is chapter 13 on wildfires. And while this is not as long as some of the other chapters we may have had, we are going to be supplementing this with some other materials and some other case studies as well. So what we don't have in notes, we'll make up in other materials and kind of make this chapter a little more robust than it is. So I'm going to get right into them. We're going to skip through our learning objectives right here and go right to first case studies. And we are going to have a couple different case studies of the various different wildfires. And these two right here were both in 2013. In fact, they're so recent that if you were to look for these locations, Black Forest in Colorado and Yarnall, Arizona, you actually would not see any fire damage because 2013 is recent enough that maps like Google Earth and other types of map software like that doesn't have current enough, I don't want to say footage, current enough images. All right, so this is in a pretty recent past. These two fires right here, the first one, the Black Forest fire. The Black Forest is an area, kind of a community, like a wooded area outside of Colorado Springs, Colorado, a little bit south of Denver, maybe an hour or so. And this one was not. They basically ruled out it was not lightning. Okay, that is, it was not set by natural causes. Now, they don't think it was set intentionally necessarily, but they think it was probably by some person who was being careless. They basically boiled it down to this was human interaction that got this fire set. But anyway, about 15,000 acres were burned and 500 homes destroyed as well. And looking at some of these homes, if you do go in and look at it in Google Earth, these older images, you do see some pretty nice homes. Very, very damaging. In fact, the most destructive in Colorado's history. But the local authorities had enough experience with forest fires to know what to do and to get people evacuated to the point where only 2 people were killed. Now, that's still a sad fact, but it could have been a lot worse. Speaking of which, Yarnall, Arizona. Now, this is kind of middle southwest Arizona, and it moved very, very fast, like the Black Forest fire. You had an area that had not received rain for a long period of time, and the ground and the brush and the shrubbery was just ripe to just go up in flames. And about 8,000 acres were burned and 200 homes were destroyed. But the real big news story here was that there were 19 firefighters that were killed when their position, this fire was just moving so fast, the position overrode where they were. They even had, well, these were like really elite firefighters. They were called the Granite Mountain, I write their name, Granite Mountain Hotshots. All right, that was... that's the nickname for elite firefighters, where they send them in and they have all kinds of equipment and skills, and they have to be very physically fit to manage rugged conditions and sleep deprivation and smoke and stuff. So these were kind of like, you might say, the Navy SEALs of firefighters, as it were, but they were overcome by flames that they're moving so fast. They even had emergency shelters that they could put over themselves to deflect the heat and possibly ride it out, but even that wasn't enough. So 19 of them were destroyed. 19 of them were killed in this blaze right here. So that was a real news story, and it woke people up to the dangers of wildfires. So let's take a look at wildfire and just look at its origins and its place in Earth's history. Fire has been around for as long as people have, and probably longer. It's one of the first recorded real bits of technology that humans were able to harness fire. And so when trees and grasses spread across the land, you would inevitably have forest fires or have wildfires, because trees were this large, dense area of fuel. When grasses evolved, grasses, especially dry grasses like that you would have in the Midwest, they go up very, very quickly. And so when grasses came around, and especially the dry kind, fires were able to burn even more easily. And so as stuff would be burned and that ash would go into the sediment, that is the ground, the fact that the ground was gaining more and more carbon and more charcoal made it, it just kind of added to the susceptibility of the environment to wildfire. So for what starts fires? Well, I mentioned earlier that in many cases it's lightning. But whatever causes fires, whether it's lightning or whether it's lava, before humans, they would just simply burn until they ran out of natural fuel, like forests, like grasslands, and that kind of thing. Humans, like I said before, could harness fires for their uses to keep warm. You could get a little bit of some sort of fuel and bring it back to wherever you lived and have that to warm your family. And fire certainly did aid populations spreading across continents, because you could, as long as you kept the fire going, you could go into an area that was not really, you might say, not very friendly to human occupation, and be able to keep yourself warm. Fires even initiate plant regrowth, because when they burn the fuel down to charcoal and down to carbon, it can add nutrients to the soil, and so new plants kind of start that cycle again of growth from what was burned out before, because of the nutrients that are in the soil. Okay, so that's sort of our introduction to wildfire. Now we're actually going to look at wildfire as a process, and this is going to be a little bit more lengthy right here. What is fire? All right. Well, fire is really a chemical reaction, naturally occurring. We would say it's a biochemical reaction. That is, all the fuel that burns naturally is biofuel, like trees and grasses and even things that were previously living but are now dead and are fire fuel. They had biological origins. All right. So very high temperature, of course, and we'll talk about the role of temperature. What is an oxidation reaction? Well, if you recall if you've ever had chemistry, and maybe you didn't, but oxidation, all right, is where atoms lose electrons. All right. Well, oxygen is an atom that rips these electrons off of these other atoms and takes it for itself. So these other atoms don't get, and the other atoms lose their electrons. And so in that process, you have combustion taking place. And we'll look at that a little bit more closely a little bit later on. But in this chemical reaction, you've got various different things being released, but heat, obviously, heat and light. When you look at fire, you might say, what is fire? That kind of flickering thing that you see. Well, it's actually kind of a gas that you see that's burning, but as that gas burns, it gives off light. That's why you see the actual flame, and of course you feel that as heat. And in order to get a fire started, any kind of fire, you do really need three different elements. You need something to burn, all right, some sort of chemical to break down and to be oxidized and carry out that combustion. You need oxygen, which is the oxidizer, and you need heat to start it off. And heat really kind of prepares the fuel to be oxidized, and then and it's able to be broken down. So things that are in plants and in trees and in many organisms are ready to be oxidized and broken down by combustion. Biomass is just naturally like that. Whether it's animals or plants, many organisms on Earth, we say, are carbon-based life forms. All right. Well, there's all kinds of carbons in our body, and one in particular. I'll show you a real simple one right here. And I messed that up already. That's all right. HC. When we say carbon-based, we actually kind of mean hydrocarbon-based. Now, this is a hydrocarbon right here. It's got 4 hydrogens, and it's got 1 carbon. All right, so we would call that CH4. That's also known as methane. All right, but many of the tissues, many of the various different compounds in our body are made up of strings of hydrocarbons. All right, we're going to see a little bit later when we look at a combustion reaction how CH4 combines with, let's see, an oxygen. So I'll write oxygen in blue right here. An oxygen, and actually no, 2 oxygens. All right, and CO2. I'm trying to balance this. I want to say 2 oxygens. and it produces heat, it produces light, and it produces some byproducts that are pretty commonplace. All right, but the point here is that that organic material that makes up many animals and many plants is ready to be broken down by oxygen and carry out the process of combustion. All right. Okay, now like I said about a minute ago, fire requires three things, and this is called the fire triangle. You can't have a triangle if you're missing one side, and you can't have fire if you're missing one of the sides of the triangle right here. So it requires oxygen, it requires heat, it requires fuel. And if you've ever used a fire extinguisher or done anything to extinguish a fire, you have done something to remove one of these three elements from the combustion process. For example, many fire extinguishers. All right, there's things. Oops, that's blue right there. I thought I had red. I'll just draw a quick fire extinguisher right here. All right. In many cases, it has that nozzle on the top right there, and you squeeze that thing, and it is a hose that comes out. All right, and two things actually come out. Well, actually, one thing comes out, but the type I'm thinking of, it puts out CO2, carbon dioxide. All right, now carbon dioxide is not oxygen. All right, so if you have this carbon dioxide coming in, replacing oxygen, well, think of it this way. You ever try to breathe in carbon dioxide? You can't, right? I mean, you breathe it out, but you can't breathe it in. So if you deprive a combustion of oxygen, the combustion goes away. The other thing that happens here is that when CO2 sprays out of these fire extinguishers, it comes out very cold. And what that cold does is that eliminates the heat. So the CO2 replaces the carbon dioxide, and CO2 replaces the oxygen, and the coldness removes the heat. And so you're removing two parts of the fire triangle all at once. Various other different fire extinguishers remove oxygen or heat in various different ways. It's hard to remove the fuel because the fuel is probably the thing that's burning, and so if you have a log that's burning, there's no fire extinguisher that's going to remove the log from the area, but you can remove the oxygen, and you can displace the oxygen and remove the heat, and that'll put out the fire. So that's the fire triangle, and all those things are required to keep combustion going.